So hello all. In this video the topic is geometrical isomerism and especially about the EZ nomenclature. So geometrical isomerism is a form of stereoisomerism describing the orientation of functional groups within a molecule. In general, such isomers contains double bond which cannot rotate, but they can also arise from ring structures wherein the rotation of bond is greatly restricted, and cis and trans both, here this is cis and trans both isomers occur in organic molecules. So actually, for example, if we consider this as the molecule, so it contains the double bond and it contains the atoms around it. These double bonds, see here, cannot rotate. These double bonds are cannot rotate, but whatever the atoms or functional groups attached to that molecules can change its position as cis or trans. So remember, cis means these atoms or functional groups which are present on the same side. Okay, so whereas trans means the atoms or functional groups which are present on the opposite side. See, for example, this is the cis, because if we consider this carbon consists these two carbons, in between them there is a double bond and it contains the methane group CH3 and hydrogen, and if these atoms are attached on the same side, see, consider this as the one side and this as the one side, so these are present on the same side, so it is an cis. Whereas if you observe this, see here, CH3 and CH3, H and H, so this is an trans because the methane CH3 groups are present on opposite side, so this is known as the trans. But specifically in this video we are only discussing about EZ nomenclature. So when there is no possibility of cis and trans in a molecule, then the EZ nomenclature involves specifically. The nomenclature of geometrical isomerism are generally divided into cis-trans nomenclature and EZ nomenclature and cis-syn anti-systems of nomenclature. Okay, so now EZ nomenclature. So basically this is cis and trans isomerism, geometrical isomerism. When this case is not possible, see here, the same functional atoms like CH3 and hydrogens are present, but in case of EZ nomenclature, the complete four different atoms or functional groups are attached to the double bond carbons. So in that case only the E and Z nomenclature takes place. When all the four substituents are different, cis trans type of isomerism cannot be applied. Okay, when these 1 2 3 4 are completely different, then this is and trans is cannot be applied in this type EZ. When in this type there are four different functional groups, EZ configuration is applied based upon the sequence rules of Can and Ingold. So according to sequence rule, and this is going to be discussed here, high priority is assigned to atoms of higher atomic number. So remember, high priority for the atomic number. Okay, for example, consider fluorine, chlorine, bromine and iodine. So this is the least atomic number compared to that of the chlorine and bromine and iodine, and chlorine is the least compared to bromine and iodine, and chlorine is greater compared to the fluorine, and same as that. So here Z means Zessuman, which is same like cis also the same side, and E which is of opposite side similar to trans. Okay, and when this EZ nomenclature takes place means when you observe the carbon, in between the carbon there is double bond and the four different functional groups are present, so then only EZ isomerism takes place. See here, fluorine, chlorine and iodine and bromine. So generally this is the same side, this should be the same side, and if this is present in opposite side, this is known as the opposite side. See here, fluorine, chlorine, iodine, bromine. So see, segregate fluorine, chlorine as one. In fluorine and chlorine, chlorine is the highest atomic number, and same in iodine and bromine. Iodine is the largest atomic number. So when you observe here, the chlorine and iodine are the highest atomic numbers in this grouping, but the chlorine is in this position but iodine is in opposite direction. So this is known as the pi. It is called as E configuration. Okay, when you observe this, see here carbon double bond and carbon, but in fluorine and chlorine, chlorine is the highest priority. In the bromine and iodine, iodine is the highest priority, and chlorine and iodine are on the same site, and fluorine and bromine, which is on the least priority, are present on the same side. So considered up as one side. So these are the same direction. So these are named as the jet configuration. Okay, thank you.